You type in a URL, you hit enter, and boom, the page is just there. It feels like magic, right? But what if I told you that in that tiny fraction of a second, your computer just sent a request on an epic journey across the globe and back? So today, we're going to pull back the curtain on that so-called magic. We're going to follow the secret path of a URL, step by step, all the way from your keyboard to a server that could be thousands of miles away, and then all the way back to your screen. Okay, so where does this whole thing kick off? It starts with the address itself. You can think of it like a really, really precise set of instructions for your browser. Every single piece of this URL has a job to do, so let's break it down. All right, first up, we've got the protocol, HTTPS. That stands for Hypertext Transfer Protocol Secure. And believe me, that S at the end is absolutely crucial. It's what tells your browser, hey, we need to set up a secure, encrypted connection here using something called TLS. This is the part that keeps your sensitive info, like passwords and credit card numbers, safe and private from prying eyes. Then we've got the domain name, www.example.com. This is the part we all recognize, right? It's the human-friendly name for the website. But really, its main job is to be a simple, memorable placeholder for a much more complicated numerical address that computers actually need to do their thing. And last but not least, we have the path /page1. This tells the server which specific thing we're looking for. A great way to think about it is like a file path on your own computer. It's like navigating through folders to find the exact document you want. Okay, so here's our first big hurdle. Your web browser? It doesn't actually understand a name like www.example.com. Nope. Computers talk in numbers, specifically numerical IP addresses, these long strings of digits you see here. So that's the problem we have to solve. How do we get from the name we can remember to the number the browser actually needs? And the solution to that problem is something called the Domain Name System, or DNS. Honestly, the best way to think about it is like the internet's giant phone book. Its whole purpose in life is to take that domain name you typed in, look it up, and find the matching IP address. Now, this lookup isn't just a simple one-and-done thing. It's actually a pretty cool multi-step dance. First, your browser is smart. It checks its own memory, its cache, to see if you've been to this site recently. If it has the IP, great, we're done. But if not, it has to ask for help. It pings a recursive DNS server, which then kicks off this chain reaction, asking other servers across the internet, until finally it finds the right IP address and sends it all the way back to your browser. All right, we've got the IP address. Now it's time to actually talk to the server. And to do that, we need to open a reliable line of communication. This is where TCP, or Transmission Control Protocol, steps in. Think of TCP as the project manager that makes sure our connection is stable and that every single piece of data gets where it's going, in the right order without any mistakes. So how do we establish that connection? Through a process called the TCP three-way handshake, which is basically a polite digital greeting. It goes like this. Your browser sends out a little packet called a SYN, which is like saying, hey, you there? I'd like to connect. The server gets it and sends back a SYN-ACK, which basically means, yep, I hear you and I'm ready to talk. To seal the deal, your browser sends one last packet, an ACK, saying, awesome, let's do this. And just like that, the connection is live. And what's really cool is how this whole process has gotten so much smarter over time. You know, back in the day with older versions of HTTP, you had to keep telling the server to keep alive the connection if you wanted to download more than one thing. It was kind of inefficient. But now, with modern protocols like HTTP/2, that persistent connection is just built right in. It's the default. And that makes loading all the different parts of a web page way, way faster. Okay, the line is open, the connection is stable. Now your browser can finally ask for what it came for. It sends out what's called an HTTP GET request. This is the official ask. It's the browser saying to the server, hey, can you please send me the content for the page located at /page1? The server gets that request, does its thing, finds the files, and sends back an HTTP response. And what's in that response? Well, it's basically a package of all the raw building materials for the website. You've got your HTML, which is the skeleton, your CSS, which is all the paint and decorations, and your JavaScript, which makes everything interactive. So now the browser has this bundle of code, the raw materials. But how does it turn all that text into the beautiful, interactive web page you actually see? That's where a super important process called the critical rendering path comes in. It's the exact sequence of steps the browser takes to turn raw code into pixels on your screen. First things first, the browser tackles the HTML.
It reads through it and builds a kind of map, or a tree-like structure, called the Document Object Model, the DOM for short. This DOM is basically a logical breakdown of all the content on the page. Here's a header, here's a paragraph, here's an image, and so on.
At the same time, it's doing the exact same thing with the CSS, creating something called the CSS Object Model, or CSSOM. This is the style map. It knows what color everything should be, what font to use, where things should be positioned. Now here's a really key detail. CSS is render blocking. That means the browser literally has to stop and process all of the CSS before it can even think about drawing the page. And that's exactly why making your CSS files efficient is so critical for a fast-loading site.
So what's next? The browser takes the content map, the DOM, and the style map, the CSSOM, and smashes them together to create what's called the render tree. You can think of this as the final blueprint for what's actually going to appear on the screen. It cleverly leaves out anything that's not meant to be visible, like an element hidden with code like display none.
Now that we have the blueprint, the browser moves on to the layout step. This is where it becomes an architect. It goes through the render tree and calculates the exact size and position of every single thing. How wide is this box? How tall is that text? It figures out exactly where everything needs to go on your particular screen, down to the last pixel. And at long last, we get to the final step, paint. This is the moment we've all been waiting for. The browser takes all that layout information, all the calculations about size and position, and it literally paints the pixels onto your screen. And just like that, the website appears. It's incredible to think that this whole super complex journey happens in less time than it takes to blink.
So that was a pretty deep dive, right? A lot of complex steps. But you might be wondering, why should I even care about all this? Well, it's not just for tech nerds. Understanding this invisible journey actually has huge real-world consequences for all of us. First off, performance. Every single step we just talked about takes time. Milliseconds? Maybe, but they add up. When a website is poorly built, it gets bogged down in this process. And that's when you get slow load times, or jank. You know that awful stutter when you're trying to scroll, or an animation looks choppy? That's jank. So making this whole rendering path as smooth and fast as possible is the secret to a website that just feels fast.
And then there's security. This is a big one. Every single step in this journey is a potential point of failure that can be exploited. For example, bad actors can abuse that polite TCP handshake we talked about to launch a SYN flood attack, basically overwhelming a server with connection requests until it crashes. Or they can use IP spoofing to pretend their computer is a trusted one to sneak past defenses. Securing this entire process is absolutely fundamental to a safe internet. So, the next time you type a URL and hit enter, maybe just for a second, think about that incredible, invisible journey that's happening. It's this complex dance of protocols and processes that we never see, but its impact on our digital lives is just massive. And it really leaves us with a big question to think about. As our world gets more and more connected, how do we keep making this journey faster, more efficient, and most importantly, safer for everyone?